Hi, this is Jani Purtee, and I want to thank you for taking time to view my ISTEM strategy presentation. This ISTEM strategy focuses on the use of the online innovation portal to enhance student learning with regards to using the design process and problem solving, and to promote the use of design-based pedagogies. Wells and Ernst, 2012, defined integrative STEM education as the application of technological engineering design-based pedagogical approaches to intentionally teach content and practices of the four STEM disciplines. Wells 2013 reminds us that technology, engineering, design-based learning is an instructional requirement of integrative STEM education. The audience for this project is Lebanon High School students, teachers, administration, and parents of students who will be using the Innovation Portal for project work. Students in the high school who are enrolled in any of the Project Lead the Way classes will be targeted for implementation. According to Jamila Silver, 2004, there is ample evidence regarding the effectiveness of a design-based approach to teaching, yet adoption of this strategy is not as widespread as might be hoped. A design-based strategy poses numerous difficulties for both teachers and students. McCormick and Murphy, 1994, tell us that teaching using the design process has been criticized by researchers who claim that it is difficult for pupils and even for teachers to learn how to use it. Coupled with this, assessment brings about another array of confusion and uncertainty regarding design-based strategies. Rigorously assessing students' design process knowledge is essential and can also be quite difficult. In creating an assessment strategy for engineering design process knowledge, the following are key criteria. The strategy must be at the individual level. It must be process-focused, not only focused on quality of end result. It needs to be reliable and consistent from student to student, project to project, and year to year. Lastly, it should be linked to more than just one level of Bloom's taxonomy. This is important because engineering design process knowledge can span many levels of Bloom's taxonomy. In order to help alleviate these concerns surrounding the use of design-based pedagogical teaching and learning, I propose that teachers and students involved with design problems are introduced to the Innovation Portal as an ISTEM tool. The portal as a strategy for teaching the design process to students provides a well-structured guide for organizing, documenting, and presenting student work in a standardized manner. The portal, used as a means to create individual student portfolios of project work throughout high school, can be valuable in demonstrating student learning and project growth over time. The portal's embedded rubric as a means for assessment gives instructors a consistent means for assessing student work and also provides a means for students to be actively engaged in the assessment as well. So let's take a look at the Innovation Portal. The portal was conceived and developed by Project Lead the Way to help highlight and promote the importance of the design process and participation in problem-solving activities in STEM education. To access the Innovation Portal, students should go to www.innovationportal.org. First-time users will need to create an account and password for their portfolio, and this can be done simply by clicking on Register at the top right of the page. Once logged in, the student screen will look like this. By selecting Portfolios on the left side menu, students can view all of their projects as tiles or as a list view if they prefer. And before we go any further, I'd like to take a closer look at the basic template used for documenting the design process. And to do this, I'm just going to open my sample project here. And you notice that down the right-hand side of the screen are letters A through N. Each letter, A through L, represents a graded step or element in the design process. M and N are intended to be used to assess student work from the perspective of the portfolio as a whole. By selecting A, or the first element in the design, we can see that it is titled Presentation and Justification of the Problem. With a click, students can view a detailed list of the required parts of this design element. Directly below this is a copy of the scoring rubric for this element. This rubric was developed through a National Science Foundation funded collaboration of post-secondary and K-12 engineering design faculty, industry representatives, and researchers. It is by no means elementary in nature and pushes students towards a much higher level of understanding of the design process while challenging them to develop and document their work at a national level. By clicking on a particular score, say 1, the rubric element becomes visible. Below this is an example of a graded project which has scored the corresponding score of 1. By clicking, students can review this example and any reviewer's comments, giving them specific guidance and editing ideas as they work through their project. This embedded rubric puts students and teachers on the same page. It outlines the goals, obligations, and constraints of all entries, providing clear criteria for evaluation, which is vital to successful assessment. According to Fernstein and Fernstein 2005, the more precise and comprehensive the rubric, the more objective the assessment. Within every project, students must set up privacy options. Portfolios will only be accessible by the student owner and to whomever they grant access or invite to view their work. With the Invite to Collaborate function, students can form teams that will be working together on a single project. Teachers can create their own standard account and be invited to view the work by their students, and from there they can manage and mentor any number of projects. At any point, students may create a snapshot of progress of their project to be submitted for review. This snapshot, along with the reviewer's comments, can be saved and used by the students for review and reflection. Once students have created their project and assigned appropriate access, they will have access to a blank portfolio template and can begin using the standard HTML editor and online tools to build any number of project portfolios. Students can easily upload documents, graphs, tables, and pictures to their projects by using the Media Center. All work is backed up and time-stamped on the hosting server on a regular basis. Creating this online portfolio of student project work is very significant. Portfolios provide an authentic way of demonstrating skills and accomplishments. They encourage a real-world experience that demands organization, decision-making, and metacognition. Used in a thoughtful, carefully planned way, portfolio assessment can foster a positive outlook on learning and achievement. Portfolios also offer a means to communicate and demonstrate student learning and success within the classroom to parents, administration, and community stakeholders. Easily accessible portfolio collections of student project work can provide a powerful documentation of student progress. Buy-in for this strategy has already been realized somewhat at all levels. At the local level, Lebanon High School administration has been introduced to the idea of all Project Lead the Way classes implementing use of the Innovation Portal. They have offered support and encouragement, stating that time and resources will be allocated for training of teachers and parents. Beyond the local level, statistics obtained from the portal show over 24,000 users and nearly 13,000 portfolios. Of the users reported, 66% are utilizing the Innovation Portal within technology and engineering classrooms. A small number report using the portal for math and science classes. The portal is currently being used at the middle school, high school, and college level. The Innovation Portal has attracted the attention of educational researchers, university faculty, and a wide variety of industries and private organizations. This map illustrates usage by state. As you can see, all states show some participation. Virginia currently has 724 participants. Because the template of the Innovation Portal is organized around the design process rather than specific lessons or topics from a given curricula, the scope of participation is open to all students regardless of geographical location or subject. Students who participate in design and problem-solving projects are highly valued by post-secondary and industrial professionals. The portal offers a standardized format and vehicle for students' work to be showcased and accessed by interested parties. A significant value realized by developing and maintaining of the Innovation Portal may be the ability to monitor, record, and report on the usage and successes of students and teachers from a wide variety of programs and backgrounds. Without such data, sincere efforts to discuss, identify, and promote best practice examples of real-world problem solving will remain isolated. The data examples and iterative conversations possible with a system like the Innovation Portal could help directly address this obstacle. Dr. Lee Apps of the University of Maryland states that as engineering design becomes increasingly embedded into K-12 curriculums, driven by Common Core and next-generation science standards, and continues to expand into all aspects of engineering and STEM-focused classrooms, the Innovation Portal could become an important trusted resource for teachers, faculty, and students.